Math 3 Lesson Summary Video, Planning a City. This lesson is a develop understanding task, which is meant to introduce you to a concept, but not necessarily finalize rules or strategies. The purpose of this lesson is to use multiple representations to solve exponential equations and inequalities. According to worldpopulationreview.com, the population of Carrboro in 2017 was 21,544 people, and the annual growth rate was 1.31%. The population of Chapel Hill was 59,862, and the annual growth rate was 0.98%. Assuming that the growth rate of the cities continues at a fixed rate, when will Carrboro become a large town? Above in your text on your task, it tells us that a large town is anything between 25,000 people and 100,000 people. So we want to know, when is Carrboro actually going to make it up to 25,000 people? So let's think about our model that we want to use. They've given us some information. We know how many people we have in 2017. So we have 21,544 people in 2017. So I'm going to let 2017 be my 0. Now, if that's my initial amount, I have my growth rate. Growth implying that it is going up. So it's going to be 1 plus 0.0131%. So this is going to be 1.0131. And then it is per year. So X is going to be in years. So my initial amount, my growth rate added to 1, and then my time period. And I'm interested in, when is this equal to or bigger than 25,000? When am I going to reach 25,000 people in Carrboro so it can be distinguished as a large town? If you recall, we have many methods that we can go about doing this. We've got multiple representations, one of which is I can look at a table. So if I go in and type into a table my model, I'm looking for, where is it going to hit 25,000? So I come down, I'm looking. Aha! So after 11 years, it was 24,860. And then at 12 years, we have over 25. So somewhere in between 11 and 12, sometime during the 11th year, more than likely, is where it's going to reach 25,000 and become a large town. So 11 years from 2017 would be 2028 is what we would estimate. Now that is an estimate because I don't have exactly where in between 11 and 12, what month during that year do we anticipate that happening. We can look at solving it algebraically. We just learned about the inverse of an exponential being a log. So I know if I can get this exponential part by itself, I should be able to do the opposite of it. So I'm going to first divide by 21,544 just to get the exponential by itself. And then once I have whatever that happens to be, 25,000 over 21,544, I can do the opposite. So I would need a log, but specifically I need the log that has the same base so that they will actually undo one another. But if I do that to one side of the equation, I have to do it to the other side of the equation. So we could solve this algebraically. If we think about our third method, we could graph it. So don't forget, when you're solving by graphing, I want to graph one side of the equation, my model side of the equation. So that's the red line here. And then I want to set the other side of the equation equal. So y equals the 25,000. And then we're looking for where they intersect. And again, it shows us that it's between 11 and 12. So 11.431 is what we would expect after 11.4 years. And again, from 2017 That's going to be sometime in 2028. We're going to expect Carrboro to reach large town status as opposed to just being a small town. In 2017, the town of Garysburg, North Carolina, had a population of 943 and is declining at a rate of 15 residents per year. The town of Conway, North Carolina, had a population of 749 and is declining at a rate of 1.6% per year. Will the town's populations ever be the same? So we're looking for when and if these two towns will ever have the same population. If I'm looking at Garysburg, so the population of Garysburg is starting at 943 in 2017, and it is declining at a rate of 15 residents per year. So we're not dealing with an exponential here. It's going down a set number of people per year. So in fact, it's going down 15 people per year. That's just linear. So we have a constant rate, 15 people per year. And so for each year, we subtract 15 people. So that gives us our population model for Garysburg. For Conway, I'm using T instead of X, so let's make sure we do that. Conway had a population of 749 to start off with, and it's declining at a rate of 1.6 per year. So that is going to be an exponential. So I need to do 1 minus 1.6, 0.016, and that's going to give us 0.984. 0.984. All right, so we have these two. We're interested in if they'll ever be the same. So if we want to find where they're going to be the same, we really want to graph them and look for where they intersect one another. So when we graph them, we've got our red line here. It started at 943 and it's going down at 15 people per year. And then our blue line is the exponential. It started at 749 and it's going down by 1.6% per year. And then we can see over here, they do actually cross one another. So they will at this point be the same. And this is predicting in 34 years. So 34 years from 2017 is going to be 51. So in 2051, we would expect that both cities would have a population of roughly 432, 33 people. So when we're trying to find places where two different situations are equal to one another, you're always looking for where they cross on the graph. That's always a great way. You can also look on the table to see where their y values are the same on the table. That is another option, and you can solve algebraically. These are all of our methods for solving any type